Hi, today we're going to be going over the problem circular barn from the 2016 February Bronze Contest. And in this video, I'll just go over the overall problem and I'll provide a hint to get you guys started with the problem. So, in this problem, there's basically a circular barn in which there are I guess, rooms inside the barn. Let's just draw that. So we have like a circle like this, and then there are barns that I guess compose this circle. And yeah, so there are n of these rooms, and so each room is connected by an exterior door, so you can like enter from the outside, and you can also walk across. I guess I didn't draw this that well, but yeah, you can basically walk through the doors to the adjacent barns. And so, okay, so Farmer John wants exactly RVI cows per room, and these cows will enter from the outside from a singular point in the circular barn, and they're going to walk clockwise until all of the rooms have exactly RVI cows. So if we look at the input, it's 5, so, well, let's just, I guess, look at this first. So at barn, n is 5, which means that the barn has 5 rooms, and then at the first room, Farmer John wants 4 cows, the second, 7, the third, 8, the fourth, 6, and the fifth, 4. And so we want to find the minimum amount of distance walked by all the cows combined. Okay, so I guess we could just, I'm not really sure how this will look, but we'll just cut it up like this. Um, so here we have and it is 47864. Okay, so let's just label it. Let's say this is room 1, 2, 3, 4, and 5. So he wants 4 cows in here, 7 in here, 8 in here, 6 in here, and 4 in here. So we have to choose an opening or an exterior door to enter at any one of these rooms in order to find a way so that if the cows walk clockwise, they will travel the least and like fill up all the barns accordingly. So let's just try simulating it where let's start here. Let's say we walk through this door. Then the first 4 cows won't have to travel any distance because they're already where they're at. So it's first 0. And then we need 7 cows to get to the first barn. So it's 7 times the amount of the distance they travel, which is just 1. And then in the third barn, we need 8 cows. And so they're going to be traveling 2 distance because they go 1 and then 2. So it's 8 times 2. And then that continues. So what we get here is 7 plus 16 plus, and that will give us 57. So yeah, so what we basically did here is we just simulated what would happen if we use the first barn's exterior door and then move the cows clockwise. And if we take a look at the input, um, the I guess constraints are very small. N is 1000 and the number of cows needed per room is 100. So since the I guess constraints are very small, um, I guess the overall solution we can use is just a simulation where we try, you know, um, simulating what would happen if we use each barn's exterior door and then calculate, compute the amount of distance traveled for each one and then take the minimum. And yeah, the output just requires um, the amount of distance traveled, so you don't even need to keep track of which barn has the least. And yeah, so that's, I guess, my first hint would be try some sort of simulation of cows walking through the circular barn. And there is one little bit more tricky part of this implementation, but I'll explain that in the next video. Thank you.